To close high-ticket deals autonomously, your AI needs to adapt live on the call. The standard approach of using static text prompts limits your bot to a fixed set of responses. Instead, we are going to build a multi-agent sales swarm that organically learns and adjusts its own parameters based on live experience. Most setups rely on retrieval frameworks, pulling summaries from a static database. We are replacing that with a training memory framework, or TMEM. Instead of feeding the AI new text prompts, TMEM uses real-time parameter updates. This allows the agents to adjust their internal logic on the fly, ensuring their behavior is shaped by the specific nuances of the current interaction. By the time we finish this build, your architecture will be able to analyze prospect behavior, patch its own tactical flaws, and autonomously navigate complex negotiations to secure revenue. Step 1 is setting up the master workspace. Here, we define the swarm hierarchy, starting with specific roles like the scout to find leads and the auditor to process the data. Next, we connect these specialized agents to a single vector database. This serves as the centralized knowledge vault, holding historical chat logs, past successful deals, and failure records. Then we deploy the swarm master on an open-source framework like OpenClaw. The most critical setting here is initializing the shared memory pool variable. Establishing this secure master control room ensures your agents can read, write, and reference the same context simultaneously, eliminating the bottlenecks that usually crash complex agent workflows. Take a look at these two models. On the left is traditional retrieval. It hits a hard cognitive ceiling because the core intelligence of the model remains completely static. It just reads from flat files. On the right is our TMEM framework. TMEM avoids that ceiling using LoRa weight updates. As the swarm interacts with clients, it uses collective reinforcement learning to physically adjust its internal parameters. It does this by scoring the outcomes of its own work. A successful audit with 0 findings acts as a positive reward, while a failed pitch signals the system to adjust its strategy. To make these updates happen fast enough for live sales, we initialize the model using singular value decomposition, or SVD. SVD strips out the computational noise. It allows the model to achieve efficient online weight convergence without needing a massive server farm to process the math. Mathematically, this is executed by a self-evolution operator. The moment a successful interaction concludes, this operator updates the agent's parameter vector on the spot. By combining these mechanisms, the AI detects weaknesses in its own logic and patches its skills almost instantly, allowing it to adapt mid-conversation. Now we equip the swarm with its sales logic. We program the agents with a closing master logic map, giving them specific instructions for psychological maneuvering. We add a recursive learning rule. If the agent encounters a new objection, it must simulate 10 different responses internally and deploy the one with the highest psychological impact. Next, we activate the psychographic analysis skill module. This tells the system to constantly evaluate the user's tone, vibe, and vocabulary choices. This document explains neuro-linguistic programming, specifically representation systems. We instruct the AI to use NLP mirroring. If a prospect uses visual language, like "picture this," the AI responds with visual terminology. If they use auditory or kinesthetic words, the AI matches that exact mode. Then we move into the operational transparency protocol, which sets up a tactic called the deep search close. Here, we prompt the AI to demonstrate its live problem-solving process directly on a call, showing the prospect exactly how the machine processes their specific business bottleneck. Running this live demonstration triggers immediate gratification. Seeing the logic working in real time positions the AI as an authoritative capital strategist, making the solution feel like a natural progression rather than a sales pitch. Launch the swarm by feeding a client transcript into the loop. Here, you see the current steps compared against new Salesforce field updates generated by the AI. Processing the transcript, it detects precise answers, categorizing the prospect's tone as high stress and analytical. Moving over to the opportunity metrics, notice the deal score rising to 58. The AI has autonomously updated its CRM strategy to a low-friction, direct approach to match the analytical tone it detected. Recalculating the deal probability and adjusting tactics after every single message ensures your system maintains tactical superiority throughout the entire negotiation. You now have a self-evolving swarm operating on your behalf. It dynamically outmaneuvers client objections, closing high-ticket deals without manual intervention. By utilizing TMEM and real-time parameter evolution, your architecture actually gets smarter and more efficient with every client interaction it completes. Your final step is to seed the swarm's baseline memory. Upload your past winning proposals and successful email threads into the database right now. To establish your optimal starting point, download the Gilded Asset folder to finalize your initial memory bank before we advance to the next phase of the build.